and welcome to this session. In this session, we will discuss advanced logic ICs focusing on their logic functions. These ICs will serve as key elements in analyzing and designing digital circuits.
Objectives. At the end of this session, you will be able to identify the advanced logic gate ICs and their operations. Universal logic gates. Universal logic gates are a foundational concept in digital electronics. These gates are highly versatile and crucial because they have the unique ability to create any other type of logic gate or circuit. Here are some key features of universal logic gates. Versatility. The key feature of universal logic gates is their versatility. You can combine them in various ways to mimic the behavior of any other logic gate, such as AND, OR, and NOT gates. This makes them extremely useful in designing complex digital circuits. Simplification of circuit design. Using universal logic gates simplifies the process of designing electronic circuits. Instead of needing a wide variety of different types of gates, a circuit designer can achieve the desired functionality using just one kind of universal logic gate. This uniformity can lead to easier manufacturing and potential cost savings. Efficiency in circuit construction. In practical terms, building a circuit with a single type of gate can be more efficient. It reduces the complexity in the layout and interconnection of different components on a circuit board. Educational and theoretical importance. In educational settings, universal logic gates are important for teaching the fundamentals of logic and circuit design. They demonstrate how various logical functions can be constructed and interrelated. There are two main types of universal logic gates, NAND and NOR gates. Integrated circuit for NAND logic gate. NAND gate is a combination of NOT gate and AND gate. In other words, NAND gate is an inversion of AND gate. It is called NAND as N stands for NOT, meaning a NOT AND gate. For two or more inputs, the NAND gate produces a high output only if one of the inputs is low. Here is the symbol for the NAND gate. The NAND gate Boolean expression is denoted by a complement of AND. Y is equal to AB bar. The IC used for NAND gate is IC7400. The IC7400 is a quad 2-input NAND gate chip, which means it contains 4 independent NAND gates. It comes in a standard 14-pin package. Here is the pin configuration of IC7400. Pins 1 and 2 are the inputs for the first NAND gate, with pin 3 as its output. The second NAND gate uses pin 4 and 5 as inputs, and its output is on pin 6. For the third NAND gate, pins 9 and 10 serve as inputs, while pin 8 is the output. The fourth NAND gate consists of pins 12 and 13 as inputs, and pin 11 as the output. Pin 7 is connected to the ground. Pin 14 is connected to the supply voltage VCC, typically plus 5 volt. Integrated circuit for NOR logic operations. A NOR gate is the inversion of OR gate or a combination of NOT gate and OR gate. It is called NOR as N stands for NOT, meaning a NOT OR gate. For two or more inputs, the NOR gate produces a high output only if both inputs are low. Here is the symbol for the NOR gate. The NOR gate Boolean expression is denoted by a complement of R. It is expressed as Y is equal to A plus B bar. The IC used for NOR gate is IC7402. The IC7402 is a quad 2-input NOR gate chip, meaning it contains 4 independent NOR gates. It comes in a standard 14-pin package. Pins 2 and 3 are the inputs for the first NOR gate, and pin 1 is its output. The second NOR gate utilizes pins 5 and 6 as inputs, with pin 4 as the output. For the third NOR gate, pins 8 and 9 serve as inputs and pin 10 is the output. The fourth NOR gate uses pins 11 and 12 as inputs with pin 13 as its output. Pin 7 is the ground connection. Pin 14 is connected to the supply voltage VCC, typically plus 5 volt. Integrated circuit for XOR logic operations. XOR gate has 2 or more inputs but a single output. XOR gate generates a high output if both the inputs are not at the same logic level, A not equal to B. Here is the symbol. The IC used for XOR gate is IC7486. The IC7486 is a quad 2 input XOR gate. It contains 4 2-input XOR gates. It comes in a standard 14-pin package. Let's see the pin configuration for 7486 IC. Pins 1 and 2 are inputs for the first XOR gate, with pin 3 as its output. The second XOR gate uses pins 4 and 5 as inputs and pin 6 as the output. For the third XOR gate, pins 9 and 10 serve as inputs and pin 8 is the output. The fourth XOR gate has pins 12 and 13 as inputs with pin 11 as its output. Pin 7 is connected to the ground. Pin 14 is connected to the supply voltage VCC, which is typically plus 5 volt. IC for XNOR gate. XNOR gate has 2 or more inputs but a single output. XNOR gate generates a high output if both the inputs are at the same logic level, A is equal to B. This is the symbol for XNOR gate. This is the Boolean expression for an XNOR gate, where this symbol represents the XOR operation and the overline represents the NOT operation. This means the output is the negation of the XOR of the inputs. The IC used for XNOR gate is IC74266. The IC74266 is a quad 2 input exclusive NOR or XNOR gate. This means it contains 4 XNOR gates inside a single IC package, and each gate has 2 inputs. Let's see the pin configuration. Pin 1 and pin 2. These are the inputs for the first XNOR gate. The output of this gate is taken at pin 3. Pin 5 and pin 6. These pins serve as inputs for the second XNOR gate with its output available at pin 4. Pin 8 and pin 9. These are the inputs for the third XNOR gate in the IC, and its output can be found at pin 10. Pin 12 and pin 13. They function as inputs to the fourth XNOR gate with the output provided at pin 11. Pin 7. This is the ground pin. It is connected to the negative side of the power supply. Pin 14. This is the VCC or power supply pin. It is connected to the positive side of the power supply, typically plus 5 volt for TTL ICs like the 74266.
This brings us to the end of this session. In this session, we have learned to identify advanced logic ICs and their operations. Thank you for joining us on this journey into the heart of digital systems. We will see you in the next session.